Okay. Hello, everyone. Welcome to the second week lecture, this doubt clearing session for CS 89 course. Um, so my name is Raj and I'm a PhD student at ISC. So I was thinking that we'll do today the quiz, uh, solutions because they're out already. So quiz one, quiz two, and the programming assignment that was associated with quiz two, right? Um, so we'll go question by question, and in case you have any doubt or something is unclear, you can let me know, and we'll dive deep in that. Okay. Um, so quiz one, first question. Any doubts here? Uh, why is how this function works, or why is the return value 5, etc., etc.? Any doubts? You can unmute and ask, right? No, no problem. All right. So here the idea is basically we are for every iteration, as long as y is greater than 3, what we're doing is we are dividing it by 3, right? So it's sort of like doing the logarithm of an integer part at least, right? That's again the feedback also that's coming here. So hopefully this should be clear. No doubts? Okay. Um, then yeah, then this question, what is f of 90 minus f of 89? Any doubts? So you see what's happening with S and uh, n mod I is basically telling you the whether it is a fact or not, and I mod 2 equal to 1 tells you whether the number I is odd or not. So you're looking at odd factors, right? And whenever you find an odd factor, you're incrementing this number S by 1. So this basically ends up listing the number of odd factors, right? Okay. So do let me know if you want to go line by line, okay? In a function. Then lastly here, so what we're doing, we're checking here if uh, I star I is equal to n. That means if I into I, that is I squared, right? If I squared equals n, then we set n to false. Otherwise, it's set to true always. Otherwise, right? So basically, we're saying that it returns, so it becomes false only when n is a perfect square, right? That is, it's a square of an integer, right? So if it is so, only then we set s to false, right? So that's therefore if n is a perfect square, that's the correct answer. Okay. Then this fourth question, does anyone have a doubt uh, why only the third option? Sorry, the fourth option is correct and not the second option. So if you think about it, if whenever m is negative, this condition becomes false. So it goes to the else, and then we're again doing m plus foo of m minus 1. So, and then we're reducing m further, right? So if m is negative, it keeps on the next recursive calls for this foo function will always be negative, right? So this condition is never true. Therefore, this particular function will never terminate for a negative number as an input. Otherwise, if the number is positive integer, then this would work, right? Then it will give you n into n plus 1 by 2. Yeah. Is that clear? Just a moment. Any doubts here? Okay. Shall we go to quiz week 2? Okay. Quiz 2. Out of the 10 statements, first question, out of the 10 statements, one is incorrect. One will generate an error. Which one is the question? So first is an assignment statement, right? So you're assigning a list to a variable, which is fine. And the list contains mixture of elements, right? Is this allowed in a list? Can list contain different type of objects in it? Yes or no? Okay. Uh, second state, so this is fine, right? Second statement is basically y is equal to x of 0 to 50, right? So we are slicing the list and we're taking from the 0th element to the 50th element, just before the 50th, right? So what will happen here? But we have only 1, 2, 3, 4, 5 elements, right? So what would happen to y? What will y get the value as? We're asking 50 elements, right, from X, but X has only 7 elements, 5 elements, sorry. Right. So, so basically here, the idea is that your first 5 elements will be used. So how many ever elements are present, if more than 50 are present, then 50 will be used. But if less than 50 are present, how many ever are present, it will assign that value to Y. Okay, is that clear? Just check that. For example, let's say if we can, um, let's say this is X, and then if I give Y is equal to this one, right? It's a print of Y. Okay. So here you can see Y is exactly what X was. Is that right? Okay. Next, uh, Z equal to Y. So this again just trying to assign a state, assign a list, assign some variable content to another variable content, another variable. So that is also fine. Z equal to Y. Then we have W equal to X. Again, just a variable assignment. Next is this X of 0 is equal to X of 0 of until 5 plus ERY, right? So with this statement, what will happen to X? Any thoughts? Just set this up. What will happen to X of 0? In general, what will happen to X here? Let me see if I can do this. Yeah. Okay. Any thoughts? If I were to print, let's say X here, what will happen to X? So Avinash is mentioning SLITHYERY. Does anyone have a different answer? Does everyone agree that it will be, so if I were to print x of 0, so one answer is basically that x of 0 would be so Dr. Yash has said all the x list plus ERY. So what is all the x list? The whole of x list, all the 5 elements. Sohail has a different answer. Slithery. Okay. So let's see what's the answer. So we'll print x of 0, or well, let's print the whole list so that we'll see what happened to on the elements, right? So you can see here, uh, uh, what was the other one? Yeah, Sohail. Sohail is right. So basically, the first element has become slith and then ERY. So remember, so what's happening here? X of 0 is basically this whole string that is slightly. Then we're taking the first 5 elements of this. So here, these are 6 character string, right? There are 6 elements in this, 6 characters. So first 5 will be SLITH, right? And then, so this gives you this gives that string SLITH, and then you're appending ERY to that string, right? So let's use debugger and see if we can do it a bit more easily. Yeah. So just a moment. Huh. So x of 0 is the first element, correct? X of 0 of 5 gives me SLITH, slight, right? And then when I add ERY, that gives me a string, which is combination of these two strings. Now, what are we doing with that, right? So we have formed the string, but we are assigning it to the first element of X, right? So the other elements are untouched. So they don't have a problem. Nothing happens to them, right? So that's why somebody else said that X will become everything plus then ERY at the end. That's not going to happen, right? So the first element gets assigned this new list, this new string that which is slithery. Okay, that's how we get this. Is that clear? Okay, so this also won't generate an error, right? So again, the question is which of the statements is going to give you an error? So this also is not going to generate an error because we're just trying to concatenate two strings and then assign that string back to some element in the list. Next, this one, y of 2 is equal to 4, right? This also again, as just like how we saw in this fifth statement, right? That we're trying to assign some value to a list element in the list. So y of 2 becomes 4, right? So if I were to print y after this and before this, let's say, right? So print of y. Yeah. So previously it was the third element was 2. Now the third element is 4, right? After the changing. So again, no issue, no problem. Then similarly, Z of 4 is equal to 42. Again, same sort of an idea. Now we'll see this element, which is basically W of 0 of 3 is equal to FEA, right? So how many of you agree that this is going to cause a problem? Any thoughts why this? So we have the answer here anyway, but why is this a problem? What is so different between statement 8 and statement 7? Statement 7 also we're trying to assign something to a list element. Statement 8 also we're trying to assign something to a list element, right? So what is the problem in these two? Right, because it's a string. So we're trying to modulate or we're trying to change a string content, right? That is not possible because strings are they mutable or immutable? Are strings mutable or immutable? immutable, right? So we cannot change the string like that, right? So this will give you an error. All right, that's exactly what they're saying, that a string doesn't support as item assignment. So you cannot assign something to a part of a string or something, right? You can concat, yes, that's correct. You can concatenate, but you can't update it. Let's just go ahead and see if other statements have a problem, right? So what is the last two statements trying to do? What will happen in these statements? So let's say if this is commented out, I mean, I would execute this, right? So let's just move ahead and see what's happening in the next statements. So what is this statement trying to do? X of 1 of 0 is equal to 555. So if I were to print X here, what would happen? Replaces 7 with 555. Yes, that's exactly correct, right? Replaces only the 7. So here X of 1 gives you the second element, which is a list. In that list of 0 we're doing, we're taking the zero index. That is the first element, right? So that element gets updated to 555. All right. So we can see that here. Okay, this is also negative, but just a moment. Yeah. So 555 here, right? Then you have this. So a equal to x of 4 of 1. Okay. So this also is throwing an error. So, but then if you go through 1 through 10, you will see that statement 8 is the right answer, because after this you won't be able to continue, right? That's the idea. So with this you'll stop. Is that okay? Is that clear? That's correct. Statement 10 also has an error. And that's because x of 4 is 0, 1, 2, 3, 4, fifth element, right? 1. You cannot do 1 of 1, right? Integer doesn't is not iterable object, right? At the end of the day. So this also will fail. Is that okay? This is question 1. Okay. Right. Next, question 2. Consider the following lines of Python code. This is all there is. Okay. Now, what do we want? At the end of this code, what is happening? So what is the right stuff that is there? So yeah. So first B is 23, 44, 87, 100. That it's a list of integers, fine. Then what do we have? We have A is B of 1 colon, right? So what will A be here? A will be a list, that much we know. So but what are the contents of A? So you can unmute and tell also, not a problem. But yeah. So yeah, 44, 87, and 100, right? We're taking from the second element. So 1 colon means second element. So this will be 44, 87, and 100. Fine. Then D is a list again, but we are saying B of 2 colon, right? So on the same lines, this is going to be 87 and 100, right? We're taking from the third element. Now C is equal to B. So C contents, we are very clear. C will be the same, we'll have the same things, but will C point to the same list as B, or it's a different list with the same contents? What does this assignment do for lists? It's the same list as B. That's correct, right? So, right. So it's not this. So C is has the same contents, and as well as basically this is the same list altogether. So that will become important going forward. But before that, D of 0 is, we are saying it's 97, right? So now D was 87, 100. So let's verify that until here, what is happening. Yeah. So very clearly, A is 44,8700, just like how we thought. B is 2344, just unchanged. C is same as B, and D is 8700. Now, D of 0 is set to 97. So that is basically the first element of D becomes 97. But D, while forming D, we didn't use equal to B. We said it's a slice of a list, right? So it's not going to change the contents of B as such, right? So this when I do, you can see here that D was initially 87, 100. Now it's become 97, 100, right? But then when I do C of 2 is equal to 77, what will happen? Because C and B point to the same list, that list contents are changing, and the change is basically in the terms of the third element becoming 77. All right. Uh, yeah. So we'll see that here. So print of A, B, C, and D. We'll print all the list. Yeah. So A is 44,8700. Again, unchanged. B is 23, 44, 77, 100, because of C of 2 equal to 77, right? Because C and B point to the same list. Again, because C and that's the whole idea. C also gets the same list, and then D is as it is, right? D is 97, 100. So therefore, the right option is this one. So third option, I guess. Yeah, third option, right? So A of 1 is 87. Uh, Yeah, A of 1 is 87. B of 2 is 77. C of 2 is 77. And D of 0 is 97. All right. Is it clear? Okay, fine. So we'll now move to question 3. Um, right. So, yeah. So, so start message is a string which has the contents called Python. End message is also a string, but it has no contents, right? It's an empty string. Then for I in range of 1, comma 1 plus length of start message, and there is something that has to be done in the for loop. All right. Um, First, before we get into what is happening, what are the values that I will take? Like what will be the uh, range of values that I will take? What will be the starting value and ending value for I in this loop? 1 to 7, 1 starting and 7 ending, right? So it will be, and why 7 ending? Because so length of start message is basically a string length function. It's going to count the number of characters in the string, right? So if you were to do this debug, yes. So length of start message is 6, right? So 6 plus 1, that's correct, 6 plus 1. So this gives me 7, right? So it's going to be a range of 1 comma 7 in some sense, right? So it will basically go from 1, 2, 3, and so on up till 7 or 6. What will be the last value of I, which I will take? Okay. So I will take the last value of that I can take by in the loop will be 6, correct? 7 is the stopping value. So range of 1 comma 7 or range comma 1 range of m comma n basically means that it will start from m and will go up to n minus 1, depending on the stop here. But the step size here we assume 1. All right. Okay, fine. So now with that in mind, what's exactly happening here? Now let's see what's happening in this one. So start message of minus I is what? What would happen in the first time? So let's just go to debug. Yeah. So now what is I first? Let's see. I is 1. That makes sense to us, correct? Because I should start from 1 and go up till 6. So what will happen after the after this one after this particular uh, you know command runs? So what is start message of minus I going to give you here? What is N, Sohail? Python. Okay. Yeah, last letter. Correct. Fine. So start message of -1 is basically N, right? So what we're doing N plus an empty string, right? So this is basically, okay, right? Going to give you again N, right? So N message was previously a empty string, right? That will become a string which has one character, which is N, right? So we'll verify that. So that is executed now. Let's see what happens to N message. That's N, right? How we expected. Now we'll iterate through again, as we know, we'll check I is 2. Yes, that's correct. What is start message of -2? So now start message of -2, right? So again, remember negative indexing, it will go from behind. It will go from last one, right? Uh, Correct. So somebody has said ON, somebody has said NOHTYP. No, no, no. So we are not doing so it is not so it's just going to give you one character, right? If I were to do something like this where I say colon, then that will give you on. Okay, that's the difference. So minus I basically means so just it's just one number, so it'll give you one character, one element in the list or string or whatever, right? This indicates slicing. So that will give you a as an output list tuple, whatever it is, right? Okay. So here, start message of minus I, it gives you O, right? Now, what are we doing here? We're saying this O you add to N. O you add to N, right? So what's going to come as output? ON, right? So ON gets assigned to end message. So end message, previously it was having a empty string. It became a string with one character, which is N. Now it became a string with two characters and the order is ON, right? So we'll just verify that end message after this one is ON. Okay. Is that clear? Right. Right. So then we will do the same thing again. So I is 3, start message of minus I is H, and then you're adding H to ON. So H is going to be HON, right? And so then you can just, let's see where we are. I is 5. Uh, let's do this. Yeah. So I've done it for a couple of times now. So I is 6, and message is YTHON, and start message of minus I is P. So it's going to add P. It's going to add YTHON string to P string, become Python, and that will get assigned to end message. Okay. Uh, and now, so I was 6. Okay, I was 6 before. Can I take the value 7? No, right? Because range works in that way that the last value is kept, right? So then it will stop here, and what you'll get at the end is uh, yeah, yeah. So what we'll get at the end is basically just the Python back, right? So hence the answer is Python. Okay, is that clear? Okay, good. Right, last question here. So question 4. So here, what do we have? Okay, so what's the question? First of all, what's the value of my list after the following lines are executed? So my list is a list. Here it has three integers, 7, 11, and 13. And we're running a function over it. My mystery of my list, right? And mystery takes basically one argument, that is L, and it takes L of one from the second element, everything, and assigns to a list L and returns, right? So here, basically what's going to happen is my list as it is gets passed to L. But then once you're doing the indexing and then assigning it to a new variable here, right? This variable has no what you can say bearing on the variable that's outside, right? So then therefore what ends up happening is your my list variable as such is remaining unchanged, right? So if I were to print my list, it's still 7, 11, and 13. Okay. Any doubts here? Return does not sending anything. Yeah, that's correct. So we don't care whether return is sending anything or not, right? Because what is the question here? The question is basically whether what happens to the list, my list here, right? That's the idea. Once again, okay. So my list as an argument is passed into the. Okay, let's just run the function. No, so let's just see. Um, yeah. So or let me just do this here. Yeah. So first no variables. So then we'll say, okay, my list is form list. And then now I'm calling this function. So it will go inside this function for execution. And inside this function, there's a variable called L. The argument that the name of the argument is L, right? So that's going to come here. So now we are currently inside the mystery function, okay, where there's a variable called L, right? And that L has three elements, same as my list, right? Now, after this, what's going to happen is L becomes 12, 11, comma 13, which is again very clear, right? Because we're doing L of 1 colon to and giving it back to L, right? Now, the return function is executed, but that we don't care about that because we care about what's happening outside the function, whether there's any change to my list or not, right? And this is what we see that my list is not changed. Is that clear? What what if I were to do something like this? So I think this is the whole point of this argument. This okay. So if I were to instead of this, I will not do this one. I'll do this. L of 2 is equal to hello. What will happen to my list? Anyone? Any thoughts? Two is exchanged with hello. I think it will show error. 7, 11, hello, and 13. Okay. Replace 13 to hello. Okay. So let's see what's happening. We'll go one by one. So again, my list is 7, 11, 13. We'll go inside the function. L of 2 is hello. We'll make that hello now. So L is changed. That's correct, right? Let's just go and so again, nothing to return. And then you can see here that my list has changed, right? That is the point of this exercise. Is not just the fact that, see, basically what's happening here is you're assigning something to the list element, but because lists are, so it basically executes this sort of a command, the C equal to B in question two when you were doing, right? So it points to the same list. That's the idea. So when you are making a change to that list, that's going to affect, right? Okay, so that will be affected. So hence the list, shows a change here. Hello. Okay.
But string
But
is
L is 7,
immutable, no,
but
sir?
the output. I'm sorry.
But the string is immutable, isn't it? How come hello is added to 17, replace 17?
No, no. Yeah. So string is immutable, but lists are not immutable. No, lists are mutable. So this L is actually a list, which is pointing to the same list that my list was there. Huh. Right. So that list element is getting replaced by a string. Yeah, that's correct. Sinan, I'm not able to understand what's the L is 7 in the sense. Okay. This L, huh? L is 7, but the output is only my list. So the print cases. No, it's not about just the fact that what you're printing. It's also about the fact that what operation you're doing on the past list, right? So here also we're printing my list only, right? But what we're changing is the question that we are seeing. Okay. So by the way, if I were to do both of these operations, what do you think will happen to my list? The question is for my list. So in this function, L of first I'll set L of 2 is equal to hello. Or okay, let me just change this. L of 0 equal to hello, right? And then I do L is equal to L of this 1, and then return from the function, and then print my list. What will happen to my list?
11 and hello will be printed.
Sorry. Uh, 11 and
13.
hello will be printed. 11 and 13. Okay. Any other answers? Hello, 11, 13. Okay. So we'll see what's happening. So we'll just skip this one now
Yes,
onwards.
it's 11 and 13 only.
Yeah. So L of 0. So L is 7, 7, 11, 13, right? Now L becomes hello 11, 13. Fine. Then L becomes a different list, 11 and 13. And then we come back to my list. So my list is now hello 11 and 13. Any thoughts what happened here? Why is my list hello 11 and 13? So somebody told correct. Avinash told correct. Okay. So what what happened?
For the zeroth index, hello got in the zeroth index.
Right. But then this statement didn't have any effect on that, right? That's the idea. So what's happening here is L of 1, when I give L of 1 colon, that's a slice of that list, and we're assigning it to some other variable, again called L. That's the idea. Okay. So this list, this L was pointing to that list. Now that list is now, the variable L is no more pointing to it because it got assigned a new list altogether. That is L of 1 colon. Okay. Which is a slice of the original list. Is that okay? Now, if I were to exchange these commands, how about now? What will be my list after executing this function, this one set of uh, command lines? Question is for my list. Hello, comma 13. Okay.
Hello, 11
What
and
else?
13.
Sorry.
Hello, 11 and 13.
Hello, 11 and 13. Okay. What else? Any other thoughts? 11 and 13. Hello, 13. Hello, 11, 13. Okay. Eleven, 13. Okay. Okay, let's see what's happening. Yeah. So we'll come here. L 7, 11, and 13. Okay. Now L gets, we're taking the slice of that list from the second element. So it's 11 and 13. That gets assigned to L. Okay. So L becomes 11 and 13. Fine. Now what we're doing, we're saying replace the first element of that list with a string hello. So L becomes hello and 13. So many of you told this is the option. Does it affect my list? That's the question. My list is still 7, 11, 13. How is this now? Any thoughts? Okay. Yes, it was not updated to my list. Why? Why was it not updated to my list? Okay, let's do this a bit. Yeah. Okay. So your mystery function. Can you guys? No, it's not showing up here. Yeah, it's fine. So this is the mystery function, right? F of mystery of L. Then we have some operations here. That is, let's say L of 0 is hello. L is equal to L1 and then return. Okay. Yeah. So now when I have a list, let's say my list 7, 11, and 13, and I call this function mystery of my list. Okay. So the way you need to think about this is something like this. So let's say your list is stored in memory somewhere, right? Which has this list element 7, 11, and 13. Okay. Now, this is what this does. This particular line of function program does. Okay. So when I'm calling this mystery of my list, internally in the mystery function, in the mystery function, this L that is there. Okay. What ends up happening is L becomes a new, let's say, entry in the memory. Let's say this is the RAM memory that you have, which points to the same guy, right? So it's sort of like this. It's saying, okay, L is the same thing. Okay. So now then what? So then what happens when I do L of 0 is hello. So because L in my list are pointing to towards the same, let's say this memory object that is there, that has 7, 11, and 13. So then it changes this one to hello. Is that clear? Okay. Then now what I'm doing, I'm saying, okay, L of 1 colon. So what will this particular part of the code is going to give you a new list altogether, right? Right? Which is somewhere in the memory, not this list, right? So it's somewhere in the memory. Let's say I will call it here. So some temporary assignment, temporary variable. This is 11 and 13. Okay. Now this 11 and 13 gets assigned to L. So L, previously it was pointing to this my list that is broken, and this L now points to this guy, 11 and 13. Okay, so therefore, whatever I do after this particular here, let's say if I were to add any more statements between this L and return, it's not going to change my list anymore. Why? Because L no more points to my list. Is that clear? So therefore, when I changed the order of operations, when I changed it like this, when I said, okay, def mystery of L is equal to, sorry, L of 1 colon, and L of 0 is equal to, let's say, hello, right? So in this case, what happens, and then, okay, return. In this case, what happens is, let's say this was my list, which has 7, 11, and 13. Okay. Now, initially, when the function got called, right, when this part of the line was executed, that is when the function was called, L was pointing to this guy, the my list. Okay. There seems to be some delay here. Okay. So L was pointing to the my list. Now, this part of the function that gets executed, L of 1 colon, right? So this becomes a new, let's say, some temporary storage, right? And this basically 11 comma 13. It's a new list altogether, which has two elements, 11 and 13. Now, when I assign this temporary list, whatever, to L starts pointing to this guy. Let me change the color. So L starts pointing to this guy. L is 11 comma 13. Now, when I change L of 0 is equal to hello, it will change this. This will become hello, right? Nothing is happening to my list. My list remains sacrosanct. My list is untouched. Does that clear things? Does that help?
Yes, sir.
Okay.
Thank you.
Okay, good enough. Fine. My list is declared globally. Yes, that is correct. Why is that a problem? Srihari, you raised a valid point, but um, so my list declaring globally is one thing. But in Python, if you want to change a global variable, you have to do something special also for that. Okay, we'll not get into that because I don't want to confuse everybody, but that's the idea. Okay, fine. So this concludes question 4 also. We'll go to the programming assignment. Yeah. Okay. Yeah. So, yeah, the first question, before we get to coding the question, somebody's asking something. Yeah, if we return, uh, L, can we will get change in list? Again, that depends. Why do you think that will affect? See the exact line that is being run in the function in the code, right? If I do return of L, is that return value being used anywhere? So mystery of my list is being called, but that function is returning something. Nobody is consuming it from the function, right? If, so this will remain unchanged. It doesn't matter on what you return. But if you were to do something like this, my list equals to mystery of my list, let's say, then of course it will change, right? So then what will happen is return of L will give you a list which is and then my list will point to that particular list, which is the whatever it happens inside this function. Is that clear? Okay. Okay, fine. So yeah, so we'll go to the programming assignment. So first question, any thoughts on how you would solve this before we get to coding? What is the what would be your approach towards solving this question? Any thoughts? So basically, you have an integer m. It's a positive integer m, and you're calling and we term this m as a prime product, right? If it can be written as a product of two primes, right? P and Q, both of them should be primes. If we can write a a integer m in that way, then m is called a prime product. Otherwise, it's not called a prime product. Okay. So, for example, here 6 is a prime product. Why? Because 6 can be written as 2 into 3. Correct? Uh, yeah, so it doesn't allow me to. Yeah. So let's just do this. Yeah. Okay. Mhm. Okay. So let's say 6 can be written as 2 into 3, right? Where 2 is a prime and 3 is a prime. Both are primes. Whereas, let's say, for example, 188, right? I can write this as into, let's say, 94, right? But 2 is a prime. 94 is not a prime, right? So this is not a prime. So 188 is not a prime product. 6 is a prime product, right? Basically, what they want is if such a number, if you can write some number as a product of two primes, you should return true, and otherwise you should return false. Okay, is that clear? Is the question clear? Okay, fine. So now, so then, what would be the approach then? How would we approach this problem? Let's say when you try to solve this 6s2 into 3, what was your approach? What did you do to see, okay, is it a prime product or not? Because that's how you will write the code also, right? The way you were thinking about a problem, that's how your code also will be written. So how would you why did you say 188 is a prime, not a prime product, and 6 is a prime product? Any thoughts? So that will define your approach. So the floor is open. If people have any ideas on how you can solve this problem, or how did you solve for the assignment? Fine. So in this case, let's say when you had to do this 6 equal to 2 into 3 or something like that, is this okay? Tell me if this approach is valid, right? So let's say if you were to do, let's say I give you number 6, you will go through all of its factors, right? Or let's start with let's say 6 only. Yeah. So we'll start with all of its factors, right? So the factors of 6 are 1, 2, 3, and 6. That's it, right? 1 divides all numbers, 6 is divides itself, and 2 and 3 are its two other factors, right? So if I were to see which are the factor pairs, basically I can write 6 as 1 into 6, 2 into 3, right? So then what I can do is I can keep going from 1 to that number, let's say, and see, okay, is 1 a prime? Then I will, if 1 is not a prime, then I will continue and I will do, okay, is 2 a prime? and if 2 divides 6, and then I will check the other number, right, with which I can get 6. Because if 2 divides 6, there's something else which if I multiply, I'll get 6, right? So then I will check, I'll get that number and then check 3, is 3 also a prime number? If that happens, then it's done, right? Then it's a prime product. Is this approach correct or not? But the 6 is not a prime number. That's correct. So see, the point is this, if it can be written as P into Q, we're not saying that it has to be always any factorization you take, it should give you both should be primes. That's not what we are saying here, right? So 6 can be, so okay, let's say for example 188, right? 188, there is no way where you will get two primes together. Either one will be prime or the other will be a not prime, or both will be not primes. So for example, let's say 2 into 94. Here, 1 is a prime, 2 is a prime. The first number is a prime. Second one is not a prime number. Or let's say 4 into, this will be what? 47, I guess. Yeah. That's 47 a prime number. Let's take 189. Make my point. So let's say, yeah, this will be 3 into 63. Yeah. 9 into 21. Yeah. So here 3 is a prime, 63 is not a prime, 9 is not a prime, 21 is also not a prime, right? So any such ordering that you take, for example, right, you will never get an ordering where both of them are prime. Does that clear the question, Sinan?
Yes, sir. Yes, sir.
Okay, fine. So, okay, so before that, then is the approach okay? If I were to do something like this, keep going from 1 to n, for example, and then see the corresponding, number, what is dividing this, input that you have, and then see if both of them are primes. Is the approach okay? Okay. If you think approach is not okay, you can tell. Matlab, if that's what it's confusing or something. Okay, fine. So people seem to agree that the approach is fine. Can we? So now think of, is there a better way to do it? Because what will happen? Just think about. Let's create a rough sketch of the code. Yeah, of how the code might look like if I were to do something like this. I would say something like, let's say for I in range of, let's say 1 comma m plus 1. M is your input, this one variable, right? Something like this, and then you will say, first of all, what you need, we need the factor. Let's say 2 is a factor of 6 and so on, so I need the factor first. So I will just do first this one. Let me not do it here at all. uh, yeah, so f prime product m, right? So then what I will do for I in range of 1 comma n plus 1, if, okay, how do we check if a number is a factor of some other number?
Percentage. Reminder.
I'm sorry.
Reminder to be 0.
Reminder to be 0. That's correct. So and how do you get a reminder? What's this one for a reminder? Using percentage symbol, right? So here I would check. I want to check whether I divides M. So M modulus or percentage I equal to 0. This tells you the remainder when M gets divided by I, if it is 0, then I is a divisor of M, right? It's a factor of M. Uh, so okay, so that's the part we came until this part, right? So we came up till this part, 1, 2, and all. We were doing the first part. I want the second part now. That is basically I want the corresponding number, which when multiplied gives me 6. How will I get that? Any thoughts? So if the approach is correct, let's try coding it up. So in this, how would you do that? Somebody wrote J. What is J? You can divide a number by prime numbers that are less than the number and check the quotient is prime or not. Correct. So Rohit, your point is correct. So we'll get there. How do you check if a number is prime or not? And that's another thing. We'll get to that. Correct. M double slash, right? That gives the quotient, right? Integer quotient in this case, and it's going to be an integer. That's fine because um, uh, it divides exactly, right? Let's say I'll call it J. Okay. So by this definition here, right? By definition, I into J is equal to M. This is for a fact, right? That's exactly what we have done here. So then what you can do, I'll have to check if let me write a helper function. Let's say is prime some let's say number uh, right? And I will not define the function as of now. Just say okay, this basically checks if number num is prime. Okay, and what it does is it returns true if if number is prime, else it returns false. We'll discuss how to implement this okay, later. But that's the helper function that we will call, right? So let's say is prime of I and is prime of J. Correct? Is this okay? So we are saying that I has to be prime and J also has to be prime. If that happens, so that means I have found a particular factorization of this particular number, right? Such that I have a prime on both the sides, I and J, both the sides. Then I will just return true because then that means it's a prime product. And then if none of this everything happens, then I will say, okay, return false. Is this okay? Please explain J equal to M double slash I. Yeah. So that's basically your um, yeah. So let's say when you have a number, when you divide, let's say you write A equal to B, P, PQ plus R, right? So let's say when you're dividing A by, when you divide A by B, right? So you get the quotient as Q, this quotient, and this remainder, right? So what we do here, so this remainder operation, one shorthand way of getting this is basically using the modulus operator, right? So A mod B or A percentage B gives you R, and A double division B, this integer division B gives you Q. Okay, that's what double, I mean, use double slash does for us. Okay. Fine. Okay. So, does anyone have a problem with this particular function? Any thoughts?
Sir, could you please explain J is equal to M double slash I1?
Yeah, that's what we did just now, right? So this is what
What I'm little
we're talking
confused.
about. Yeah. So let's say if I were to divide a by b, let's say there's an integer a and I divide it by another integer b. So generally, what you can do is you can write it as a form in this way, where you can write a is bq plus r, where q is the quotient that you get from by this division, and r is the remainder that you get, right? So basically, r, the remainder, a way to get the remainder when you divide a by b is this modulus, that's the percentage symbol, right? The quotient is this, right? Now, in our case, what are we doing? Let's say, so in our case, what do we want? So let's say I have, when I divide m by I, so divide m by I, right? This is what we are trying to do right now. And we know for a fact that the remainder is zero. So m mod I is we have, I mean, this when the we get to this line, correct? Only when m mod I is zero. So now that means the remainder is zero in this case. Okay. Now what we're doing, so m division by I will give you, let's say, some number, let's say I'll call it j. What will, uh, what does this mean? It means that I can write m as I into j plus 0, right? Same like this. Okay. Uh, Let me not do that. So ij plus 0, I into j plus 0, which is basically ij, right? Which is exactly what I want, because what are we trying to do? We're trying to say, okay, I'll go through, I'll go through all the numbers from 1 to n, right? And whenever a number divides the we find a factor, I want the corresponding number, which when multiplied with this gives me the number back, right? Which is exactly what's happening here, right? So if I have I, I'm getting j by doing this particular operation. Is that clear?
Yes, sir, that's clear. Thank you.
Ah, okay. So people seem to agree that okay, this is the right uh, thing to do. So then fine. So then let's fill up the uh, is prime function. How would we do this? How do you know if a number is prime or not? What's the code?
Number
How
mod
will we code for this?
number number modulus 2 is equals to 0.
Number modulus 2 equal to 0 will tell you what? What is it
Oh,
has the
sorry.
remainder.
Sorry. It's even.
Yeah. So number mod 2 equal to 0 gives you the remainder
Yeah,
of
yeah, yeah, yeah.
when
It's
divided by 2. So that will be, uh, yeah, it will be even or odd. That's the thing. Number is prime if it's odd number. All odd numbers prime numbers? What about 9? Is 9 a prime number? No, right?
no.
Right. So uh, how do we define prime numbers? We look at the factors, right? So again, same sort of idea here. So we want to get the factors of this number num, let's say, right? So what I can do is something like this for I in range of. So 1 is always a factor. So let's just exclude that for now, and num, and then we'll see. Until num will do for a reason. So if num mod I equal to 0, return false. Otherwise, return true. So think of the exact thing that's happening here. So what are we saying? We're saying that I will go from 2. Okay, we'll start from 2, this checking, and num is the second argument to range. What does that mean? It means the I will go from 2 to num minus 1, right? So I will go from 2 to num minus 1, inclusive. It's the inclusive range that we're talking about, right? So if any of the numbers between 2 and num minus 1 divide the num, right? that means it's not a prime number, correct? Because the only factors that a prime number will have is 1 and itself. So 1 is anyway, there's no point to check that here, that we know for a fact. And itself also, there's no point to check. We know for a fact that every number divides itself. So the biggest point is check between 2 and num minus 1. Is that okay?
Yes, sir.
Does this do the line 2 to 7, the function which checks if a number is prime or not, does that make sense? And then if that is correct, and if it's correct, then this should be fine. So is this okay for a first cut of the solution? Okay. Okay, fine. Fine. So we'll just call this, let's say, version 1. Okay. Somebody else also told something like this, right? So where we said we can do it on only for prime factors in the first place. Why go with, every number from 1 to m? You only if the factor is a prime, if the first factor is a prime, only then you do it, right? So that makes sense. So for that, what we'll do first, we have to go one by one. You have to check primes, right? So for that, what we'll do this 1 comma m plus 1. Then if m percentage I equal to 0 and is prime of I, right? So what does this line do? This tells you, okay, I has to be a factor of m, but I has to be a prime factor of m, right? Only then you get into this loop, right? Then you can do this exact same thing. I want to find the opposite of that. I mean, the other number, which is which when multiplied with I gives me back m. And now I just check if E is prime of j, because we know I is already a prime. I into j is m. So if j is also a prime, then this would be a prime product. Is that so? Does this make sense? Is let me call this version 2. So so is version 2 okay? Any issues in version 2 implementation? Okay, all okay, fine. So fine. So this is good enough. Can we think of any way to make it more efficient? So now let's think about the problem, the question a bit more. Okay. So a positive integer m is a prime product if we can written as p into q, and p and q both are primes. Okay. So so if that's the case, if a number is such, if a number is like this, p into q, where p and q both are primes, what are all the factors of m? If this is true, if a number is a prime product, let's say, what are all the factors that the number will have? Can you think of something here? So what are the factors of a prime product? One, p, q, and the number itself. One is common to all. Okay, fine. Milind has a answer, which is one p and q, one p, q, and the number itself. Anybody who disagrees with that answer? Can't there be any other factors? So let's say M is P into Q, where P and Q are primes. Okay, are primes. So then uh, how many of you think um, let's not go there. So let's say this example that we had, right? This example that we had about 189. Okay. So 189 is 3 into 63, right? Now we also could make it into 9 into 21, right? This so think about why we got this 9 into 21, because the 63 can again be broken down into 3 into 21, correct? And then I can multiply this 3 and 3 to get 9, and 21 remains as it is. Okay. Now, if I had a number which was P into Q, and P and Q both are primes, this is also prime, this is also a prime, right? This is prime, this is prime. Can I break down this Q into anything more different so that I can multiply with this P and get a different number? Any thoughts on that? Would it be possible to do something like how we did for 189? Can we do that for something which is in which both are primes? No, right? That's the whole idea. So here, because we know that in any prime, you can only write as, let's say, if P is a prime, then you can just write it as 1 into P. Nothing else will work for it, right? So therefore, uh, if M is a prime product P into Q, the number of factors, I mean, the factors that M will have will be only 1, P, Q, and M itself, right? So Milind was right. Anyone who has who contests this point is important for us to do the next version of the code. That's okay. That does that make sense? 1 P, Q, and M, right? So now with this information, that prime product has such special numbers that you have only 1 P, Q, and M. Can we think of how to improvise this prime product? And think of why you want to improvise. See, the point is this. Here you're iterating through all the numbers from 1 to M. You find some number, some factor, and then you go back to doing this prime calculation, right? Again, you go through all of those numbers. So you're doing this sort of very, I mean, two sort of loops and all of that. So if there is a way to solve, if there is a way to make it a bit more efficient, we should try. So now, given the fact that prime product numbers have these 4 factors, can you think of what would be a better way to solve this problem? Any thoughts? Maybe find P and Q. No, but that's exactly what we were doing here, no? Uh, your name is P and M. So finding P and Q, that's exactly what we were doing here. Because see, once you find I and J, exactly what we have. This is the P and this is the Q, right? And by the way, what is the problem statement? You just want to find whether it's a prime product or not, right? Is there any use for you to know what the the primes are for the particular question that has been asked to you, right? Uh, do you want to actually know what the P and Q are? Can you think of it a bit in that sense, in that lines, and using this particular fact? Any thoughts? No? Okay. So how many? So okay. So then, if M is a prime product, we know that there are these factors. What are the number of factors of a prime product? Four. Correct. A prime product has four factors, which is very clear for us, right? Now, if I were to check just the number of factors that a number like M has, would it be sufficient to say that if the number has four factors, four distinct factors, that's a prime product? Would that be a fair assumption, a fair thing to do?
Yes.
Right?
Yes, sir.
Right. Okay. Uh, can we use in range M mod I equal to 0?
Not
Mm,
scanning, sir.
I'm sorry.
No need to scan the range, total, all range of numbers. Directly selecting all for P and Q numbers, including
No.
one of the M number.
No. That is correct. How will you directly select P and Q? You can't select P and Q, no? You don't know what P and Q are.
You have to check it in the is prime.
Is
P
prime.
and Q
Okay.
yeah, is prime. Then accepting those P and Q.
No, but that's exactly what we were doing here, no? In some sense, because we are saying that okay, if M mod I is 0, and then I and J are obviously factors of M. And if I is prime and if J is prime, then we are done. That's exactly what we were doing here, no?
Yeah.
Huh. So see, the point is this: to solve this particular question, you don't need to know what P and Q are. That's the biggest point here, right? And the fact is that this two and the number of factors for a prime product will always be 4. That is the key. So for that, what we can do, let's say, so what I will do is I'll maintain, let's say, a factor list or factors as a list, right? So for I in range of 1 comma n plus 1. So basically what I'm doing is I'm just listing out all the factors. Just get me all the factors of M, right? How will I do that? What's a factor? If it divides this one, right? So M mod I equal to 0. What I will do? Okay, how do I add a number inside a list? Now this is a list. I want to add this I number in this list of factors. How do I do that? What do I write here?
Finding the M, sir.
Correct. Okay. Uh, okay, good. Everybody has told the word append. Fine. There's one person who has told this. Where is this guy? PNM. Yeah, this is. So people who have gone through week 3 lectures will say append. Who haven't gone through that will say off I. Both are correct. Not a problem. Okay. So, and okay. So what do you want to append though? Do you want to append M or do you want to append I?
M, sir.
I want the factors of M. So M divides I is 0. That means I is a factor of M. So I want to append I in the factors list, not M, right?
Yes.
So factors or append of I. Either you do this or somebody was saying this, right? So you can write factors plus and then bracket of I, right? So this is a list. You do list concatenation with another list. So you're making a list of one element, that is I. these two lists will get concatenated, becomes a new list, and that list gets appended, becomes the factors list. Okay, both are fine. For now, don't worry about this, which is a better among these two and all of them. Okay, so factor dot append of 5. Then what do I do? What's the final check? We discussed something, right, about the number of factors. Four factors only. That's correct. So therefore, yeah. So we just need to check the length of factors, right? So how do you do length of factors? This is a list. Length of list is given by length of factors, correct? So let's say I'll call this as number of factors equal to length of factors. So if number of factors equal to 4, then I will return true, right? I'm rushing a bit because we are almost out of time. Else, I will return false. Is it okay? Does this implementation make sense? Any doubts? Anyone has any problem with this implementation? Okay.
Yes.
Okay, perfect. Now, I'll argue that. Okay, somebody has a question. But then, for example, 10, 1, 2, 5, 10 are the factors. No, sir. Yes, so 10 is a prime factor, no? Prime product. Because 10 can be written as only 2 into, can be written as 2 into 5, where 2 and 5 both are factors. So 10 is a prime product. Okay, fine. So now I will argue that there's even a better version than this. Right? There's a better version for this. Okay, so again, think of this argument that we have, right? We just want to know the count of factors. Is there any use to know what the exact factors? Is there any use to build this whole factors list from beginning? Any thoughts? Hey, come on. So, so do you want to know the factors in this particular problem that's been asked to you? We only care whether the number m is a prime product or not. That's it. We don't care about what factors they are, which p and q and all of that. We don't care about that. Correct? So, does it make sense to maintain a list of factors? No, right? So what we will do, we'll make it a bit more better. We'll say number of factors. We'll just keep counting number of factors. So initially we'll say a number of factors is 0. And whenever I find a factor, what I will do? What I should do, ideally, to this number of factors that is there, this variable. What should I do this to this number of factors variable? I should increment it, correct? So I can just say number of factors plus 1. That's right, increment, right? Now, that's it. So there is no need to store any factors. You just need to store one integer and this will give you an answer. Okay. Now there is slightly more thing that you can do. So think about, do I need to go through this whole loop for every possible number? Let's say, for example, like number like 189 that we had as an example. right? So what will happen to the number of factors when it goes? It'll try, okay, first one divides 189, then 2 doesn't divide, then 3 divides 189, then 4, 5, 6 doesn't divide, 7, 8, 7 divides, right? Then 9 divides, right? And then it keeps on doing that. So do I need to wait for the whole list to get completed? Can I do something intelligent there? So Sinan KP. So you have an idea, but that there's a problem in that. We'll discuss that. But the thing is this: there's no need to go through the whole of the list, right? So what I can do is, I mean, all of the numbers between 1 to m. What I can do is I can just here itself we can keep checking, right? The moment number of factors goes above 4, I don't care anymore, right? I don't care anymore. So I can just return false. I know for a fact that the number of factors, if it goes above 4, I'm done, right? It is not a prime product. So therefore, and then just return true at the end. Oh, no, this is not true. So you have to check again here. So number of factors equal to 4, then you will say return true, right? Otherwise return false. Right? So this sort of a check will basically help you to stop the loop immediately, sort of, right? Yeah. Okay. Does that make sense? So this is a slightly improved version upon this, because here you are storing all the factors which we don't need. We just need the number of factors at the end of the day for a prime product problem. Okay. Yeah, that's exactly what what the point is. So if number of factors is less than 4, what cases are such where number of factors is less than 4? Can you think of some numbers which have less than 4 factors? One itself, okay. So then is 1, 3. Maybe 2. So basically prime numbers, right? Prime numbers have only 2 factors. So number of factors is always 2 for prime numbers, right? So that's exactly why we have another check here. So now, okay, so then the question is this: are prime numbers themselves prime products? So let's say I have a prime number like 3, right? The only way I can write 3 in a factor form is 1 into 3, right? So then is 3 a prime product? No. 3 is not a prime product. Why? Because I can write 3 as 1 into 3. 3 is a prime number, but is 1 a prime number? So 1 is neither prime nor composite. Okay, these things you need to know a bit. Okay, so 1 into 3, so 1 is neither a prime nor a prime, not a composite number. So prime numbers are themselves not prime products. So number of factors, if it is exactly equal to 4, only then it's a prime product, otherwise it's not. Okay, so this thing helps when you have non-prime and very large numbers, which basically have more factors. So this basically stops the loop in between, and therefore it's a slightly bit more efficient version of what you were trying to do. Okay. So there were some ideas on up to half the number, up to square root. Yes. So you can use this sort of ideas also. So in that, what will be the check you will do, and what will be the range that you will go up to? So okay, so we'll do this another version. Let's say prime product P prime M. Yeah. So for I in range of, let's say Milind brings a good point. 8 also has 4 factors. So then you will not, yeah, then you have to do the square root version. Right. So then you have to do the square root version. So for example, like this, something like this, right? So you can say 1 comma, let's say I have the square root of m. So Python itself has the inbuilt square root function in the math library. All right. So what you can do is something like this. So int of square root. Then what you will do here. So basically the idea is this, right? So let's say if you have so let's say if you have something like this, any number, let's say when you're dividing with m by let's say a, right? So you to find the maximum sort of a factor that you let's say if you were to arrange all of the factors of m in this order, let's say 1 into m and then 2 into whatever so on. Uh, what are the number of these elements, number of these pairs will basically be up to the square root of m, right? Because whenever you have a number here, the if this number is less than the square root, this number is going to be greater than the square root, right? That's the idea. So if I go up till the square root, that's enough. That's the idea. Okay. So here I can do until square root of m. And then, so then in this case, what will be the way you will decide on number of factors? So time space, see time space complexity. Yeah. So it depends on whether the conditions are helping it or not, right? For in this case, for example, in our use case, so we had this, for example, yeah, here, for example, right, is prime and all of that. So here, the time complexity was more, and space complexity was, let's say, just you just had one integer you in some way, right? Just holding 2, 3 integers here and there, right? So in that case, then obviously, but then going to this prime, this factors sort of version, that will basically make it a bit more time efficient. But let's say it has worse, not better, let's say space complexity, right? That sort of a thing. So it depends on uh, how your conditions are helping you or not. That's the idea. Okay. So in the square root version, for example, how will we go about doing this? So what will be the, let's say the number of factors in this case? How would we, how many factors would we have? Up to square root, how many factors would we get, for example? Any thoughts? So we'll have 2 factors, right? So then we just need to do something like this, right? So, okay, so just have num factors equal to 0. And then your check is going to be if num factors is equal to 2, right? This would be your uh, sort of implementation that you can do. Okay. Does that make sense? So because here the idea is that P and Q, this will be basically divided by the square root, this one. So here P would be, if P is less than square root, Q will be surely greater than square root. So we'll have two factors that you need to check for. Okay. Fine. So, so does this help? Shall we move to second question? Del char?
Yes, yes, sir. Yes, sir.
Okay.
Let's move to second question.
So del char function, for example, here, let's do that. So what's the idea here? So we're saying that it takes as input strings S and C, where C has a length 1 is a single character, and returns the string obtained by deleting all occurrences of C in S. If C has length other than 1, then the function should return S as it is, right? So for example, here, banana B, for example, then A should come out. All the things of this second string that is passed should be removed in this first string, right? And then let's say if the second string is more than one character, you just return the first string as it is, right? So any thoughts how we can get started here? Let's say we'll start with V1. First check in if condition length of S is greater than 1. Length of S is greater than 1, okay? Yeah, this will be a good check to have. So if length of S is greater than 1, what you would do? Only then you will go over doing it, is it? But what if it is equal to 1, or if it is length of C, correct? Length of C, if it's greater than 1, then what do? What's the output? So that's very clear, right? So if C has length other than 1, then the function should return S, right? So what you will return in this case? Just S, correct? Okay, but you're saying length other than 1. So let's say if C is even empty string, right? Exactly. So not equal won't be the right way of taking this, right? So if length of C is not equal to 1, then you return S. So because C can be an empty string also, it's no characters, for example, right? Okay, fine. So now, any thoughts on how will we solve this problem? So this is the first simplest use case that we have that is solved. Now this one, the next part of it, the main bulk of the matter. In this, how will we go about doing it? Any thoughts? Find C in S, replace. String has a replace function. Using for is one option, yes. So let's say S is okay. So let's say A with some B, it'll replace that. So then, so replace option is there for a string. So how would we use replace option? What will be replaced with what? So S dot replace I can do. So what I have to replace? C, right? And blank, how would we say blank? Empty string, that's it, right? I think this should work, right? So let's say if I were to do something like this, banana A with empty, so it's giving us BNN, right? It's as simple as that. So it's a string operation that you can use. Yeah, no space again. Yeah, just make sure there's no space here. It's literally nothing in between the quotes. Yeah. So with this, it just replace whatever the characters are there in S, which are same as C with empty string, right? So that will cause all your other letters to come together. Okay. Does that help? Okay. Yeah. Okay. Got it done in first version only. Fine. Next, last thing about shuffle. I guess second question is fine. Third question will go to shuffle. So in shuffle, the idea is that you have two lists, L1, L2. Okay. And so it takes two lists and returns a list consisting of the first element in L1, then the first element in L2. Can you tell another version without using replace? Then you will do basically your for loop, right? So, okay, let's just do another version. So say V2. Okay. So this is fine. Then what you will do, you will say for char in S. So now what you're doing, you're going through each and every character in S one by one, right? And what you will, the idea is that if the character is equal to C, right, then we don't want to take it in the string anymore, right? So then basically the simple check is if char equal to C. But what do you want to do? You want to remove that in some sense, or basically you want a string output such that that particular character is missing, right? So what we'll do, we'll make another string here. Let's say a red s, that is return string. That'll be our output this one. Um, and then what we'll do, we'll say, okay, if character is not equal to C, then red s equals red s plus char. Right? So what it will do, it'll just keep on going through the characters in the string. If the character is not equal to C, okay, if the character is not equal to C, only then you add the character to the string that you want to return. And then you will basically return that is. It's just, okay. So somebody said for I in yes. Yeah, that's exactly what we're doing, right? So hell, yeah, correct. This is that version. Does this help? Okay, fine. So then let's go to the shuffle wala. Um, Yeah, return a list consisting of the first element in L1 and then the first element in L2 and second element and so on. So basically what you want to do in this is the simplest example that we have. We'll go from first want 0, then we want 1, then 2, then 3. So you basically need to keep going one after the other from one list to the other list, right? And whenever something ends, whatever is there in the other list, you just append it, right, to the output list. Okay, so fine. Any thoughts? How will we do this? So L1, L2 are the two lists. First find minimum of length of L1 and L2. Who said that? Yeah. Why? Okay. Why do you want minimum of length of L1 and L2? Does anyone have a thought on that? Why finding out the minimum length of L1 L2 would be useful here? Okay, so think of this like this, right? So basically, you want to know how many times you will have to scan the arrays, scan the two lists, right? So if you have 3 and 3, basically you have to go one after the other 3 times. Here, you have to go one after the other only one time, right? 0 and then 1, because after this one, there's nothing else anything else left in the second list. So then you can just take whatever is pending in the first list, right? Uh, we can add directly both. After that, the balance will print without shuffle, right? That's exactly what we want to do. So first, so let's just get the this one. So L1 length is length of L1, right? Len function gives us the length of the elements. Okay. Now you want the minimum length. So how would we get the minimum? If L1, so I'm rushing a bit here, we are a bit out of time. So L2 length, right? So minimum length is L1, right? If this is the case, else minimum length is L2. Does that make sense? And see here, they can be of equal length. In that case, we'll say minimum length is L2 length, but we'll see that, I mean, it doesn't matter. If two numbers are equal, what is the, which one is minimum is both a minimum or both a maximum, right? So it doesn't matter to us anyway, fine. Now what you want, we want to give out a list. Yeah, we can do minimum of length of L1, length of L2, you'll get the minimum length, that's correct, right? But what you want to do here, you want to iterate from that, um, zeroth, element to the minimum length list that we have, right? So how would we do that? We'll go for simple for I in range of minimum length. Okay, is that clear? So now what you want, we see here, we want to make a new list altogether, which has all these shuffled elements in it. So let's initialize a list. Let's say ret L is a return list, for example. And then what we will do here, now see, until minimum length, because so this basically tells us that there are at least minimum length number of elements in both the lists. So I can happily index elements in both the lists and keep adding to the ret L. So ret L dot append of the first list L1 of I, right? Ret L dot append of L2 of I, right? So this is how we are shifting list 1 and list 2, right? So here what will happen? First I will say this line will tell me list 1 ka first element, so it will be 0. Then it will go to list 2 ka first element, that is 1, that is this line, right? So then what's happening in ret L, you're getting 0, 1, 2 from both the lists, right? Now this part is over, the hard part is over. We just need to now get the remaining elements in the whichever is the bigger list. Now how do we get that? So the hard part is over. We had to go from shifting from between one list to the other. That part is over. What else? How do we basically I need to add uh, uh, add whatever elements or
Max
append
elements.
max what?
Number of elements. Then the max.
But we don't have max here, and yeah, so we can use extend. That is correct. But extend what? Can you tell what will be the command, the program here, line here? So we can use, people who have gone through, it's week 3. So you can use extend, right? L1 of minimum length colon. Okay. And the same for L2. Okay, this is a nice approach. So you can just do this. Why will this work? Let's say if L1 is a shorter one, then minimum length of colon will just give you an empty list, right? There's nothing in that list anymore after minimum length. So therefore, this will be an empty list, and extending an empty list is fine. It will not add anything. Versus same thing. So let's say if L2 is a bigger list, then whatever elements are present after minimum length will get added here. Will get appended in this RETL. Okay. So this is all, and then just to return this RETL here. Okay. Is this clear? I know we rushed a bit in the last this one, but is this okay? Final doubts on question 3. No? Okay, fine. Fine. So we'll close the session here. We'll meet on regular timing on Tuesday, 6 to 8. Same link, and so we'll do week 3 lectures a bit, right? Whatever you have doubts there, we can clarify that in that session. Okay.
Can
Fine.
we change to the next days?
No. So no. So times are actually fixed by NPTEL, so we don't have a much leeway in that. But anyway, no, we can't change it like that. So see it. Correct, exactly. So we have record of all the sessions, so you can check there. Okay.
Thank you very much.
Okay, I'll stop the recording now, right? Okay, see you all next coming Tuesday. Yeah. Okay.